You are tuned to Iri-e-learning, and I am your host, Teacher. In this periodic table and periodicity lesson, we will examine the reactions of group 7 elements, which are called halogens. Check the description box for links to all the lessons related to this unit. By the end of this lesson, we should be able to describe reactions of group 7 elements. For a quick recap on reactivity, recall that group 7 elements react by gaining 1 electron on their outer shell to complete the 8 electrons. Now, it becomes difficult for the larger atoms to gain an extra electron as the atoms increase in size due to shielding by the many inner-lying electron shells. Therefore, reactivity decreases down group 7.
Reactions of halogens, group 7 elements. Based on what we have just learned, the reactivity of the halogens decreases down the group. Therefore, fluorine is the most reactive and iodine and astatine are the least reactive. In this segment, we will only examine the reactions of chlorine, bromine, and iodine because fluorine is highly toxic and difficult to handle, and astatine is radioactive. Before you proceed, ensure that you have reviewed the videos on writing chemical formulae and writing balanced chemical equations. This is essential to improve your understanding of the formulae and equations written in this section of the lesson. We will begin with the reactions of halogens with metals. Now, halogens react with metals to form the metal halide. And as we learned in our previous lesson, metal halides are called salts. Now, the halogens react less vigorously going down the group because the atoms get larger and it becomes progressively harder for the larger atoms to gain additional electrons. So just keep in mind that the halogens react with most metals to form the metal halide, which is a salt. To compare the reactions of chlorine, bromine, and iodine, we will use the same metal, and in this case, we are going to use iron wool. Note that iron wool is a silver gray solid with a very fibrous texture. The first halogen metal reaction we will discuss is the reaction of chlorine with iron wool. Chlorine, a pale green gas, reacts with hot iron wool to produce iron 3 chloride, also known as ferric chloride. Note that iron 3 is also referred to as ferric. Iron 3 chloride is an orange-brown solid as shown in the sample. It is slightly soluble in water and it is used in the treatment of sewage and industrial waste. Let's watch a short video clip on the synthesis of iron 3 chloride. Next is the reaction of bromine with iron wool. Bromine is a volatile red-brown liquid. When heated, copious amounts of the vapor is evolved, which is then made to react with hot iron wool to produce iron 3 bromide, also called ferric bromide. Iron 3 bromide is a red-brown solid as shown in the sample. It is soluble in water and it is hygroscopic, meaning it absorbs water from the air. The third reaction is that of iodine with iron wool. Iodine is a solid at room temperature. However, when heated, the solid sublimes to give off a violet vapor. The vapor reacts with the hot iron wool to produce iron 3 iodide, also called ferric iodide. Ferric iodide is a black solid which is not stable in ordinary conditions, and as a result, we do not have a sample to show. Here is a quick comparison of the reaction of the 3 halogens with hot iron wool. Chlorine reacts vigorously, bromine quickly, and iodine very slowly. Therefore, we can clearly see that the reactivity decreases down group 7. The next set of reactions for comparison are the reactions between halogens and hydrogen. Now, when halogens react with hydrogen, chemical formula H2, they produce colorless gases of the hydrogen halide, general formula HX, where H comes from hydrogen and X can be substituted with the symbol of the halogen with which the hydrogen reacted. Also note that hydrogen halides, when dissolved in water, form acidic solutions. So keep in mind that hydrogen halides are produced from the reaction between hydrogen and a halogen. It's time to compare the reactions of the three halogens with hydrogen. Chlorine reacts explosively with hydrogen in sunlight, but the reaction is less violent in diffuse sunlight, and there's no reaction in the dark. What we have is that chlorine reacts with hydrogen to form hydrogen chloride, formula HCl, and hydrogen chloride, when dissolved in water, produces hydrochloric acid, which is a very common laboratory acid. Bromine reacts moderately with hydrogen at 300 degrees Celsius in the presence of a platinum catalyst to produce hydrogen bromide gas. And of course, the formula for hydrogen bromide is HBr. Note that the extreme conditions of the high temperature and the use of a catalyst are necessary for this reaction to occur. Iodine reacts very slowly with hydrogen at 300 degrees Celsius in the presence of a platinum catalyst to produce hydrogen iodide, chemical formula HI. This reaction also requires extreme conditions to occur, and even then the process is very slow. Note that the reaction is reversible as represented by the reversible arrows in the equation. Reversible arrows mean that the reactants combine to form the product, and the product dissociates to reform the reactants. In other words, iodine combines with hydrogen to form hydrogen iodide, and hydrogen iodide then dissociates to form iodine and hydrogen. This reaction goes back and forth until an equilibrium is achieved. Once again, we can clearly see that the reactivity decreases down group 7, moving from explosive to moderate to very slow. Halogens also undergo displacement reactions, in which the more reactive halogen displaces or takes the place of the less reactive halogens in a solution containing their salts. Recall that the salts of halogens are called metal halides. For example, potassium chloride. Potassium, the metal, has bonded with chlorine, the halogen. Potassium bromide. Potassium is the metal, bromine is the halogen. And potassium iodide. Potassium is the metal, iodine is the halogen. So keep in mind that a more reactive halogen will displace less reactive ones from solutions of their salts. Two changes occur when the reactive halogen displaces less reactive ones from their salts. First, the more reactive halogen takes the place of the less reactive halogen in the salt, and two, the less reactive halogen leaves the salt and forms the diatomic form of the element. Here we will view an animation that demonstrates the two changes that occurred during a halogen displacement reaction. Before starting the animation, recall that a more reactive halogen can displace less reactive ones from their salts. Therefore, chlorine can displace bromine and iodine from a solution of their salts. Bromine can displace iodine only, and iodine is unable to displace chlorine or bromine because it is the least reactive of the three halogens on the list. Back to the animation. The reaction involves the more reactive halogen, in this case we're using chlorine, displacing the less reactive halogen, in this case bromine, from its salt, and the salt we're using is potassium bromide, KBr. To start the chemical equation, as we have at the bottom of our screen, notice we have one molecule of chlorine, Cl2, reacting with two molecules of potassium bromide, KBr. Note that we're using chlorine water instead of chlorine gas, hence the state symbol AQ for aqueous. When the reaction occurs, the atoms for the more reactive halogen halogen, in this case chlorine, displaces bromine, the less reactive halogen, from its salt. The less reactive halogen then forms the diatomic element Br2. Therefore, to complete the equation of the reaction, the products formed are 2 molecules of potassium chloride and 1 molecule of bromine. The bromine formed is dissolved in water within the reaction mixture, hence AQ as a state symbol. We will now take a closer look at the displacement of bromine by chlorine. This animation will be twofold. To the left of our screen, we will observe changes that occur at the atomic level between the reactants, and to the right of the screen, the changes we would observe when performing the experiment. In this experiment, we have 2 reactants: chlorine water, which is a very pale green solution, and a colorless solution of potassium bromide. Note that potassium bromide is the metal halide, or the salt of the less reactive halogen, and of course chlorine is the more reactive halogen. When a drop of chlorine is added to the potassium iodide, notice the solution changes from colorless to orange brown. The color change is due to the formation of the element bromine in the aqueous state. Since chlorine, the more reactive halogen, displaced bromine from its salt, the final products are 2 molecules of potassium chloride, KCl, and 1 molecule of bromine, Br2. Chlorine, being the most reactive of the 3 halogens that we're looking at, can also displace iodine. So the 2 reactants that we have are the more reactive halogen, chlorine, Cl2. We are using chlorine water, which is a very pale green solution. The less reactive halogen, iodine, we're using a colorless solution of its salt, potassium iodide, Ki. Therefore, the chemical equation, we start with the reactants: 1 molecule of Cl2 reacting with 2 molecules of potassium iodide, Ki. When a drop of chlorine is added to a colorless solution of potassium iodide, the color changes to brown as iodine is displaced from the salt to form the diatomic element I2. Consequently, the products are now 2 molecules of potassium chloride, KCl, and 1 molecule of iodine, I2. Next, we have the displacement of iodine by bromine. Since bromine is higher in the group of these 2 halogens, then bromine is more reactive and can displace iodine from its salt. So the reactants are the more reactive halogen in the form of bromine water, which is an orange-brown solution, and a colorless solution of potassium iodide. As a result, our chemical equation begins with a molecule of bromine reacting with 2 molecules of potassium iodide. When bromine water is added to the potassium iodide solution, note that the colorless solution changes to brown due to the formation of iodine in solution. Therefore, the more reactive halogen, bromine, displace iodine from its salt to form potassium bromide, and the less reactive halogen, iodine, forms the element I2. In completing the chemical equation, the products are 2 molecules of potassium bromide, KBr, and 1 molecule of iodine, I2. Finally, iodine, being the least reactive of the 3 halogens, will not be able to displace the other 2 from solutions of their salts.
The lesson summary points are as follows. Halogens react with metals to form the metal halide, which is a salt. Halogens react with hydrogen to produce a colorless gas of a hydrogen halide. A more reactive halogen can displace less reactive halogens from a solution of their salt. It's quiz time. You have 5 seconds to answer each question after it is read aloud. Question 1. 3 halogens X, Y, and Z are listed in order of increasing reactivity. Identify the statement that is correct about the reactivity of these halogens. A. Halogen X is the most reactive. B. Halogen Y is the most reactive. C. Halogen Z can displace Y and X from their salts. D. Halogen X can displace Y and Z from their salts. The answer is C. Halogen Z can displace Y and X from their salts. Question 2. Identify the equation that shows a reaction that will occur. A. Chlorine reacts with potassium bromide to produce potassium chloride and bromine. B. Bromine reacts with potassium chloride to produce potassium bromide and chlorine. C. Iodine reacts with potassium chloride to produce potassium iodide and chlorine. D. Iodine reacts with potassium bromide to produce potassium iodide and bromine. The answer is A. Chlorine reacting with potassium bromide to produce potassium chloride and bromine. Note that bromine is less reactive than chlorine, so it cannot displace chlorine from its salt. That makes B incorrect. Iodine is less reactive than chlorine and bromine, hence cannot displace these halogens from their salts, making C and D incorrect responses as well. Question 3. There are 3 halogens, P, Q, and R. Use the information below to arrange the 3 halogens in the order of their increasing reactivity from left to right. Q displaces R and P. P cannot displace R. The options are A. QPR, B. PRQ, C. PQR, D. QRP. The answer is B. PRQ. Since Q displaces R and P, then Q is the most reactive. And if you're going to be listing them in order of increasing reactivity from left to right, then Q must be to the right because it's the most reactive. Then P cannot displace R, which means that P is less reactive than R. So P would be the least reactive of the 3. So listing them in order of increasing reactivity, meaning from the least reactive to the most reactive, we have PRQ. Question 4. What product is formed when a halogen reacts with hydrogen? A. Hydrochloric acid, B. Hydrogen halide, C. Metal halide, D. Halogen hydride. The answer is B. Hydrogen halide. Question 5. Halogens react with metals to produce the metal halide. Which reaction below is likely to occur vigorously? A. Iodine plus aluminium produces aluminium iodide. B. Chlorine plus aluminium produce aluminium chloride. C. Bromine plus aluminium produce aluminium bromide. D. None of the above. The answer is B. Chlorine plus aluminium producing aluminium chloride. Now, of the 3 halogens listed, chlorine, iodine, and bromine, chlorine is the most reactive of the 3. Hence, its reactions would be more vigorous with any metal compared to the other 2 halogens.
We have reached the end of our lesson. If you found this video helpful, remember to like, share, and subscribe. When you subscribe, you will receive notifications as new videos are uploaded. So until next time, I am Teacher with Iri-e-learning.